Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi students, our topic today will be on antiviral drugs 2, part 2. In this lecture, we will continue our lecture on antiretroviral drugs. First of all, let us revise again the goals of our retroviral treatment. First, we want to improve the quality of life and prolong the life of our patients. Then, to reduce HIV-related morbidity and mortality. To achieve reduction in viral load. To restore and preserve immune function, to minimize side effects of drugs, and finally to reduce HIV transmission. In the previous video, we have learned on these 5 groups of antiretroviral drugs and their set of actions. For the next slides, we will cover all the groups in a little bit more detail. Are you ready? Let's go. The first group is the nucleotide or nucleoside reverse transcriptase inhibitors, or in simple form, we call it NRTI. Actually, the difference between nucleotide and nucleoside depends on their phosphate structure. However, in general, they are the analog of purine or pyrimidine bases that made up the RNA chain. For nucleoside reverse transcriptase inhibitors, the examples are zidovudine, the thymidine analog, stavudine, thymidine analog, didanosine, adenosine analog, lamivudine, a cytidine analog, M3-citabine, cytidine analog, and abacavir, guanosine analog, and nucleotide reverse transcriptase inhibitors, tenofovir, which is adenosine analog. Next group is non-nucleoside reverse transcriptase inhibitor, such as nevirapine, efavirenz, and etravirine. And then the third group is the protease inhibitors. The examples are lopinavir, ritonavir, usually used in combination with other protease inhibitor as a booster, and also ritonavir, boosted lopinavir as a monotherapy, indinavir, atazanavir, and darunavir. The fourth group is the integrase inhibitor. The example of integrase inhibitor is raltegravir. And the last group is the fusion or anti-inhibitors such as enfortumab and maraviroc. Each of these drugs has a different mode of action. They will be explained after this. Now, let us look at the mechanism of action of each of these group of drugs. The first group is the NRTI. What they do are, they will act as competitive inhibitor of reverse transcriptase. It will compete with the host nucleoside base in the growing viral DNA chain to cause chain termination. Before we go further, let us watch this video.
After entering the cytoplasm of a CD4 cell, the uncoating of the viral core then occurs. The matrix core disintegrates, releasing the capsid with the HIV genetic material and associated enzymes into the host cell. The capsid then sheds its coat. The 2 viral RNA strands, which are coated, and the viral enzymes are then released into the cytoplasm. This now leads to the activation of the reverse transcriptase enzyme. The conversion of viral RNA into single-stranded DNA can now begin. The reverse transcriptase, or RT, now moves along the HIV RNA molecule and copies it into viral DNA through the incorporation of naturally occurring nucleosides. The nucleoside reverse transcriptase inhibitors, or NRTIs, compete with naturally occurring nucleosides to prevent their incorporation into viral DNA, and this in turn prevents reverse transcription. The reverse transcriptase enzyme embeds the NRTI nucleoside analog or inhibitor into the synthesized molecule of DNA. As a consequence, natural nucleosides can no longer be added to the growing viral DNA chain, which is thereby terminated. Hence, this process is called chain termination. Consequently, the completion of reverse transcription cannot take place. Hence, the HIV DNA is not fully formed and cannot be incorporated into the DNA of the host cell.
Right. The second group is the NNRTIs. As the name suggests, the NNRTI are not the analog of purine or pyrimidine. The action is more directly on the reverse transcriptase enzyme itself. They will bind directly to the reverse transcriptase and cause inhibition of the enzyme. Due to this feature, these drugs have less effects on host and less cross-resistance with the NRTIs. The third group is the protease inhibitors. As mentioned before, HIV protease enzyme is responsible for the cleavage of a large or long protein into a number of essential viral enzymes during assembly and binding process. This is essential for the production of mature infectious variants. So these protease inhibitors will block the activity of the viral protease enzyme. This will lead to prevention and maturation process of the new viral particles and make it non-infectious. The fourth group is the integrase inhibitors. As mentioned before, integrase is the enzyme produced by the retroviruses that enables the genetic material to be integrated into the DNA of the infected cell for further transcription and translation processes. Thus, the integrase inhibitors block the action of integrase that will result in the inhibition of a complete viral replication. The last group is the fusion or N3 inhibitors. As mentioned in the early slides, there are two drugs that belong to this group, and each of them has a different mode of action. The first drug is enforvitide. This drug will bind to the glycoprotein 41 structure of the HIV that will prevent conformational changes of the host cell membrane and inhibits fusion of the virus into host cell. The other drug is maraviroc. It is a CCR5 antagonist. CCR5 is a co-receptor that works together with glycoprotein 41 to facilitate HIV entry through the membrane into host cell. Okay, that's all for now. Hope to see you again in my next video on antiretroviral therapy or ART. Assalamualaikum. Bye-bye.